Hi, welcome to the Division of Education, Innovation and Energy e-learning program. I am one of your maths facilitators, Frederick, and in this video, we shall be looking at the topic of algebra. So we looked at the definition of algebra and all the terms that come along with a study of algebra. The next thing that we want to look at is evaluating the value of an algebraic expression. What if we found out the values of the variables in an algebraic expression? Can we then determine the values of the expression? Yes, we can. Yes, we can. Yes, we can. The rules for evaluating the values of an algebraic expression. What are those rules? Rule 1. Replace each variable with the number it represents. Rule 2. Evaluate using the laws of integers and BODMAS. In our last video, we looked at integers and the laws that govern integers. So if you are unfamiliar with these laws, then please check our last video for an update before you continue. So let's look at an example. Again, here we have an algebraic expression that we saw from before. The algebraic expression x minus y squared. But here, we now know that x is equal to 2 and y is equal to minus 3. Because the question states, given that x is equal to 3 and y equal to minus 2, evaluate the value of the algebraic expression x minus y squared. So the expression that we have is x minus y squared. We have been told that x is equal to 3 and y is equal to minus 2. What are our rules for evaluating the value of an algebraic expression? The first rule is to replace each variable with the number it represents. Here, x represents what? X is represented by 3 and y is represented by minus 2. So what we shall do is that we shall rewrite this expression here, replacing the numbers with the values that they represent. So x is 3 and y is minus 2. So we now have it is 3 minus 2 and brackets all squared. This therefore becomes, working out here, rules of integers again. If I have double signs, the double signs, once they are the same, are to be replaced by a positive sign. So this becomes 3 plus 2, and we are squaring all of it. What is 3 plus 2? 3 plus 2 is 5. 5 squared is 5 times 5, which is 25. Look at another example. Given that a is equal to 4, b is equal to minus 5, and c is equal to 2, evaluate the following algebraic expressions. A squared minus 3ab minus b squared. How do we do that? Again, remember that we are to replace a is what? A is 4. What is b? B is minus 5. And what is c? C is positive 2. So we are to rewrite this algebraic expression, but as we rewrite it, we are going to replace every single variable by the number that it represents. A is represented by 4, so we replace the a by 4, so it becomes 4 squared. And so it's a squared, but now I've replaced my a with 4. Minus 3ab. Remember, a is 4. What is b? B is minus 5. And what is 3ab? 3ab is 3 multiplied by a multiplied by b. So it's going to be minus 3 multiplied by a. I put my brackets. Brackets also means multiplication. So it's 3 brackets. What is a? A is positive 4 by b. What is b? B is negative 5. And then it's going to be minus b squared. So it's minus, what is b? B is negative 5. So it's minus negative 5 squared. Now remember, when we are simplifying our algebraic expressions or when we are simplifying or evaluating numbers, we need to utilize BODMAS. BODMAS tells us that we must do brackets if brackets are there. But here is what, as we did speak to in our integers, if there is only one number in the bracket, then there's nothing that we do. So we go on to the other part of BODMAS, which is order. And order speaks to powers and roots. We need to do our powers. So doing our powers here, this becomes 4 squared is what? Minus 5 squared is what? 4 squared is 16, minus 5 squared is 12. Watch here. It is negative 5 squared, but there's still a negative sign in front here. So I must rewrite my negative sign and then do the negative 5 squared. Negative 5 squared is negative 5 squared is going to be negative 5 multiplied by negative 5. Negative multiplied by negative is going to be positive 25. So this here is positive 25. Remember, if it's positive, we don't have to write the sign. We then go on to do our multiplication. What is negative 3 times positive 4 times negative 5? It's going to be positive 60. So it gives us here 16 plus 60 minus 25, which gives us 51. Let's look at another example. Looking at another example here, we have 4ac minus b to the power c all upon 4a. Again, we need to, if we are to evaluate this, the value of this algebraic expression, once we know the value of a, the value of b, and the value of c, we are going to replace a, b, and c by the numbers that they represent or that they are equal to. So, doing our replacement here, a was 4, c was negative 5, and b here, look at this one here. This is negative b to the power c. What is b? B is negative 5. So it's going to be negative 5 to the power of c. What is c? C is 2. So it's negative 5 to the power of 2. All upon 4 times a. Utilize BODMAS and your laws of integers. We then come down to here that this negative 5 squared here, negative 5 squared, we looked at negative 5 squared already. Negative 5 squared is positive 25. Using our laws of integers, we have, it is negative 80 subtract 25 all upon 16, which gives us negative 105 all upon 16. Remember, when we were doing integers, negative 105 upon 16 is the same as negative 105 divided by 16, which you can use your calculators here. It is negative 6.56. Before we continue, we want to look at there are 3 basic binary properties that we utilize: the commutative property, the associative property, and the distributive property. As we navigate algebra, we shall explore all of them. But here, we want to look at the commutative property. The commutative property simply states that addition and multiplication is commutative. When we say that, what do we mean? We simply mean that being commutative, we can have this. What is 3 multiplied by 4? 3 multiplied by 4 multiplied by 5. 3 multiplied by 4 multiplied by 5. 3 times 4 is 12. 12 times 5 is 60. So this here is 60. Look at this one. What is 5 multiplied by 3 multiplied by 4? 5 multiplied by 3 multiplied by 4 is going to be 5 times 3 is 15. 15 times 4 is 60. What about this? What is 4 multiplied by 5 multiplied by 3? 4 times 5 is 20. 20 times 3 is 60. Here we recognize that regardless of how we arrange the numbers in this multiplication problem, the answer is still the same. And that's the commutative property. The commutative property says that the ordering of the numbers does not matter. The answer for multiplication and addition only would remain the same. So we can in doing our multiplications and our additions, we can switch around our numbers, change the ordering of our numbers. The answer is still going to be the same. That's the commutative property. So here for addition is the same for addition. 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is 12. This here is going to give me 12. What about this one? 5 plus number wrong. Before we continue, let's just look at the commutative property. What the commutative property says is that addition and multiplication are commutative. When we say commutative, what does that mean? Look here. What if we had 2 plus 3 plus 5. What would that give us? 2 plus 3 plus 5. 2 plus 3 is 5. 5 plus 5 is going to be, that is going to give me 10. What about this one? 5 plus 3 plus 2. 5 plus 3 plus 2 is going to give me what? 5 plus 3 is 8. 8 plus 2 is 10. What about this one? 3 plus 5 plus 2. 3 plus 5 is 8. 8 plus 2 is, again, 10. So here we see that regardless of how we arrange the numbers, the answer is still the same. And that's basically the commutative property. The commutative property says that here, the operations, there are 4 basic operations that we know: addition, subtraction, multiplication, and division. Of those 4 basic operations, addition and multiplication are commutative. What it says is the order does not impact the answer. So when you're working problems that involves purely addition and or multiplication, you can rearrange them. Yeah? Once it's purely addition or it's purely multiplication, you can rearrange them. The answer would still be the same. So that's basically our commutative property. Here we have 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is, this here gives me 12. This one, 5 plus 3 is, 5 plus 3 is 8. 8 plus 4 is, this again gives me 12. 4 plus 3 is 7. 7 plus 5 is 12. Regardless of how we arrange these numbers, the answer remains the same. That's your commutative property. It also applies to multiplication. Here we go. 3 times 4 is what? 3 times 4 is 12. 12 times 5 is going to give me, that's right, 60. Remember that if you need to develop your skills mathematically, your first check has to be your ability to multiply. Most persons who have problems with mathematics, it's centered on they not being able to multiply. So please spend some time learning your multiplication. What about this one? 5 times 3. 5 times 3 is what? 5 times 3 is 15. 15 times 4 is going to give us 60 again. What about here? 4 times 3 is 12. 12 times 5 is also going to give us 60. So again, we see here that regardless of how we order these digits or these numbers, once we are multiplying them, the answer is still the same. And that's the commutative property. Addition and multiplication are commutative. Now that we have that, let's look at the addition and subtraction of algebraic terms. For the addition and subtraction of algebraic terms, here are the rules or the steps that we need to follow. Step 1, identify the like terms and group them. What does that mean? Let's see. Step 2, add and subtract the terms by adding and subtracting their coefficients. We saw coefficients before. Coefficients we said were the constants or the numbers that once an algebraic term is written in standard form, then the numbers in front of these algebraic terms are our coefficients. So here we are saying for rule 2 that when we are adding and or subtracting algebraic terms, we need to add and subtract the coefficients of the like terms using the laws. Remember, the laws of integers applies once we are doing any sort of calculation in mathematics. So that's our steps. Remember that only like terms can be simplified when adding and or subtracting terms or expressions in algebra. Like terms. When we say like terms, what exactly do we mean? We use like terms here. We use like terms here. We use like terms here. We have been using like terms for a while. When we say like terms, what do we mean? Like terms. These are terms with the same variables raised to the same powers. Let's go that again. Like terms are terms with the same variables, and these variables must be raised to the same powers if they are to be like terms. So again, let's just recap that. What are like terms? Like terms are terms with the same variables, and the variables are raised to the same powers. Here we have some terms that you may meet across when you're doing your mathematics. What are the like terms here? The question says, identify the like terms in the expression below. What are the like terms? Here I have 12x. 12x, remember what we said like terms are? Like terms are terms with the same variables. So if there's a term that is like 12x, it must have the same variables as 12x. What is or are the variables here? The variable here is x. This only has x. So this 12 here would be like some other term that has only that variable x. Well, here's x standing by himself. Where coefficient, what is the coefficient of x here? It does not mean that x is that value. The coefficient is the number in front of. The coefficient of x here is 1. So here we have 12 with a variable x raised to what power? Remember we said that if we see no power, the power is 1. Here, this x has no power, so its power is also no visible power. So its power is also 1. The power is not 0. If we see no power, the power is 1. So that's right. Those two are like terms. Do you see any more like terms here? Yes, we do. What about these two? This here is negative 5xy. The variables are x and y. So if there is a term that is like this, it must have the same variables like it. Here, this is positive 12. The variables are x and y. The powers on each of these variables here is 1. The power on each variable is 1. Likewise here, the power on each variable here is 1. So these two are like terms. Any more like terms you see? Correct is right. Here, the x is squared, the y is cubed. If another term is like this term, then the x must be squared and the y cubed. So these two are like terms. Do you see any more like terms here? Yes, they are. Look right here. Here again, like terms, remember what like terms are? Same variables raised to the same powers. Here the x is to the power 5 and the y is to the power 3. Likewise here, the x is to the power 5, the y is to the power 3. And these two as well are also like terms. This here, the r is to the power 3, the t is to the power. Remember, if I see no power, the power is 1. Here, for this term, r is to the power 3, t is to the power 1. So these here are again like terms. Any more like terms? Yes. Here we have variable a being squared, variable a being squared. Those are all the variables for these two terms. So these two terms are like terms. So let's just go back a bit. Let's just go back a bit. And we said that when we are adding and or subtracting terms in algebra, when we are adding and subtracting terms in algebra, we need to identify the like terms. And we have been able to identify our like terms. So what are the steps when simplifying algebraic expressions utilizing addition and or subtraction? Let's just recap on them. Step 1, identify the like terms and group them. And step 2, we are to add and or subtract the terms by adding or subtracting their coefficients or the coefficients of the like terms utilizing the laws of integers. So here we have a problem that involves some simplification of an algebraic expression where addition and subtraction is taking place. Step 1 says identify the like terms. What are my like terms here? 3y is a like term. My like terms here, 3y, like term, 8y squared like term, 5y like term, 7y like term. So what we are going to do is that we're going to group the like terms together. Grouping the like terms together, we have 3y squared minus 8y squared. These are all my terms. We say that these terms are terms in y squared. So all my terms in y squared are 3y squared and negative 8y squared. Now, here's one. When we are moving our terms about for addition and subtraction, when we are moving them, we need to ensure and move them with their signs. So here, my 3y squared was positive. He was first, so I left him first. But what I did was to bring the 8y squared closer to him. It was negative 8y squared. So when I move that negative 8y squared in my expression, I must also move it with its sign. So it's going to be 3y squared negative. I am moving it with its sign. So this 5y, which is positive, he has to move and make space for the negative 8y squared. Moving it, I need to move it with its sign. So ensure that when we are rearranging our terms in our algebraic expressions, that we rearrange them with the signs that are in front of them. So it's 3y squared minus 8y squared plus, I'm moving that down, 5y squared. I'm now moving the 7y to bring it closer to the 5y. The 7y is negative. Signs are very important in mathematics. So it's plus 5y minus 7y. I'm moving the 7 down some more. Again, when you're moving them, you move them with their signs. So it's going to be negative 7, and then the plus 9 comes to the end. So working this out here now, what does it become? It becomes, when we are, step 2, when you are adding and or subtracting terms in algebra, you are to add or subtract the coefficients of the like terms. So here now, we have like terms, 3y squared, negative 8y squared. Utilizing my laws of integers, I am to add or subtract my coefficients of my like terms. 3 minus 8 is going to give me negative 5. They are terms in y squared, so my answer is going to be a term in y squared. We don't subtract the variables or the exponents. Likewise, positive 5y minus 7y, we are adding and or subtracting the coefficients of the like terms. So it's going to be 5 minus 7. What is 5 minus 7? 5 minus 7 is negative 2. It is negative 2y. And finally, numbers. Negative 7 plus 9. Negative 7 plus 9. If you remember the laws of integers, if the signs are the same, we add them and keep the sign. If the signs are different, once we are doing addition and or subtraction, if the signs are different, we subtract the smaller number from the bigger number, and the answer is going to be that of the bigger number. Let's look at another example. Look here. Remember what we said like terms were. Like terms must have the same variables. In addition to that, the variables must be raised to the same powers. So here we have a case of a term in x to the 5th power y. It is 2x fifth y plus 3x squared y cubed plus xy minus 5x squared y cubed plus 4x fifth y plus x squared y cubed. Our first step when we are doing addition and or subtraction of our algebraic terms, our first step is to identify the like terms. What are our like terms here? This first term is 2x raised to the power 5 y. So this here is a term in x fifth y. A like term is going to be any other term or terms that are in x fifth y. Let's scan along and see. Any term in x fifth y? Any term in x fifth y? Any term in x fifth y? Here is one. This is another term in x fifth y. According to our step is that we need to group our like terms. So this term in x fifth y has to be grouped with the next term in x fifth y. Group those terms together. We need to group our like terms. Here, the next term now is a term in x squared y cubed. A term in x squared y cubed, that's my next term. Let's check and see if there are any other terms in x squared y cubed. Here's one right here. This is negative 5x squared y cubed. This is another term in x squared y cubed. Are there any more? That's right. Here we have another one. This is a term in x squared y cubed. Remember, when we are moving them, we need to move them with their signs. So this term here is negative 5x squared y cubed. We are grouping these terms together. So we're grouping these terms together. What is that going to give us when we group our like terms together? This is what we get when we group our like terms together. So all the terms in x fifth y are together. All the terms in x fifth y are together. All the terms in x squared y cubed are also together. And then we have this solitary term here in xy. So there's nothing to group that with. So we shall keep writing that as we come down in our working. Working it out here, we have, remember, that when we are adding and or subtracting our terms in algebra, we add and or subtract the coefficients. For my term here in x fifth y, the coefficient is 2. For my term here, it's positive 4. So we are going to add the coefficients here. It's going to give us 6x fifth y. And here, what do we have here in terms of x squared y cubed? In terms of x squared y cubed, it is 3x squared y cubed minus 5x squared y cubed plus x squared y cubed. I'm seeing a coefficient here. That's 3. I'm seeing a coefficient here. That's negative 5. What is the coefficient here? Remember what we said. If we see no coefficients, one still exists. What is it? The coefficient is 1. That does not mean that x is 1. It simply means that the number in front of the coefficient, or of the algebraic term, that number is 1. So adding and or subtracting our coefficients here, we have 3 minus 5. Remember the laws of integers. 3 minus 5 is negative 2. Negative 2 plus 1 is going to give me negative 1. So this here is going to be 6x to the 5th when I work out this piece here. And then When I work out this here, I get minus 1x squared y cubed, and then my solitary term, who cannot be added and or subtracted to anybody. Why is that? Because that rule says that only like terms can be added and or subtracted when we are doing algebraic addition and or subtraction. Let's look at multiplication of algebraic terms. Let's recall before we do, when we were looking at converting from an algebraic statement to a worded statement and vice versa, we did say that 5a is 5 multiplied by a. Once we have a number and a variable next to each other, or numbers and variables next to each other, the operation that is occurring there is multiplication. So this here is 5 multiplied by a. Similarly, 3m squared n fifth is really 3 multiplied by m squared multiplied by n to the power 5. Number constant and variable together, multiplication is taking place. Let's also recall the commutative property. The commutative property says that addition and multiplication are commutative. So as we saw from before, that this here gave us 60, this gave us 60, this gave us 60. It's the same numbers. The only thing that has changed is the ordering of the numbers. Changing the ordering of the numbers once you are doing multiplication or once you are doing addition does not change the final answer. So we can rearrange our numbers. Let's use that here for multiplication. So look here. So this term that we have here, 3m squared n fifth, is the same as 3 multiplied by n fifth multiplied by m squared. Before we saw it was 3 multiplied by m squared multiplied by m fifth. But we are saying, utilizing the commutative property, 3m squared n fifth is also 3 multiplied by n to the power 5 by m squared. Utilizing that, let's see if we can use that as we do some multiplication of algebraic terms. Now for multiplication of algebraic terms, here's a rule that I want you to learn. The rule is, when multiplying algebraic terms, once the variables are the same, we add the powers or exponents. So here, the variable here is m, the variable here is m. The power here is 3, the power here is 2. Since the variables are the same, once we are multiplying them, we are therefore going to add these powers. So my answer here is really m to the power 3 plus 2, which gives me m fifth. Once you are multiplying terms in algebra, what we do is that we add our exponents. Let's apply that here. 4a multiplied by 7a cubed. 4a, so here, the coefficient is 4, the coefficient here is 7, the variable here for this term is a, the variable here is a cubed. So this therefore gives me, if I were to expand this based on how we did when we were establishing algebraic statements from worded statements, we said that 4a is really 4 multiplied by a, and that 7a cubed is going to be 7 multiplied by a cubed. That's what we said. And what we're then going to do is that we are then going to apply that commutative property. Commutative property, multiplication is taking place here. We are multiplying. So it is 4a multiplied by 7a cubed. But according to the commutative property, we can rearrange them. Rearranging them here, utilizing our commutative property, it becomes 4 times 7 times a cubed. We know that 4 times 7 is what? 28. And what is a times a cubed? Utilizing this rule, that once we are multiplying and the variables are the same, we add the powers. The power on this a here is 1. The power on this a is 3. We are multiplying, so we shall add those powers. It is going to be 28 multiplied by a to the power 4, giving me my answer as 28 a to the 4th power. We looked at the basic rules for multiplying algebraic terms. Let's apply those basic rules. Here we have 3m squared n fifth multiplied by 5m to the power 4 n. Again, as we stated from before, this is really 3 multiplied by m squared multiplied by n to the 5th power. And this one here is going to be, it's 5 multiplied by m to the 4th power multiplied by n. Now we are multiplying these two terms. So these two terms have been multiplied. Multiplying these two terms, what is that going to give us here? Utilizing our commutative property, we are going to rearrange them. So remember, according to the commutative property, we can rearrange them and the answer is still going to be the same. So this is 3 multiplied by 4. Sorry, that's not 4, that's 5. That's 3 multiplied by 5 multiplied by, I'm putting my m's first, so it's m squared multiplied by m to the 4th power. M to the 4th power multiplied by n to the 5th power multiplied by n to, well, there's no power there. But remember what we said, even if we don't see a power is still there, that power is 1. So multiplying my constants here, or my coefficients, I have 3 times 5 is 15. And once the variables are the same and we are multiplying, we add the powers. So this is going to be multiplied by m to, we are adding the powers. So let's add our powers. It's going to be m to the 2 plus 4. And multiplied by again, multiplied by n to the 5 power plus 1. That gives me here now 15 multiplied by m to the 6th power multiplied by n to the 6th. My answer is therefore 15 m to the 6th power n to the 6th. And that's my final answer for that one. What about this one? 3x squared y 5th multiplied by 5x 4th y 4th. My argument remains as well that this here is going to be, expanding it out, it's 3 multiplied by x squared multiplied by y to the 5th. Now, we usually, when doing algebra, we usually make this argument that we try to distinguish between our x's and our multiplication symbol. Some people continue to write the x's as I've written my x's here, and that makes it a bit challenging to understand. So when we're doing our x, we write it as 2 back to front c's and try to see if you can do that. That usually helps in understanding or simplifying the understanding of algebra and or to distinguish between algebra and multiplication. And it's going to be, so I have already 3x squared y 5th, which is 3 multiplied by x squared multiplied by y 5th, multiplied by 5 multiplied by x to the power 4 by y to the power 4 as well. Utilizing the commutative property, we rearrange them. So this here becomes 3 multiplied by 5 multiplied by x squared. I'm putting my x's first. X squared. We usually write them in alphabetical order. Multiplied by x to the 4th power multiplied by y to the 5th multiplied by y to the power 4. Using our rules again, so we simplify our coefficients. My coefficients here 3 and 5, I'm multiplying. So it's 15 multiplied by x squared multiplied by x to the 4th power. Once the bases are the same, we add the powers. So it's going to be by x to the, adding my powers here, it becomes 2 plus 4 multiplied by y to the, again we are adding our powers. Here. So adding our powers here is going to be multiplied by y to the 5. It's going to be y to the 5 plus 4, which therefore gives us 15 multiplied by x to the, adding the powers is going to be 2 plus 4 is 6 by y adding the powers is y to the 5 plus 4 is 9. Giving me here 15 x to the 6 y to the 9 power. Right. So we have looked at addition of algebraic terms. What about division? If when we are multiplying, we add the powers, what do we do when we are dividing algebraic terms? What do we do? You are correct. If when we are multiplying, we are adding the powers, when we are dividing, what we do is that we subtract the powers. Look at this example here. 28a divided by 7a squared. So again, we are going to work out the coefficients by themselves. So it's going to be equal to 28 divided by 7. And next we have, it's a divided by a cubed is going to be a to the power 1 minus 3, which gives me 4a to the minus 2. 2 power. 1 minus 3, utilizing our rules from integers, 1 minus 2. 1 minus 3, sorry, is minus 2. We have looked at multiplication and division. And what I want to leave you with are just some basic laws of exponentials. Now remember that with multiplication we said once the bases are the same, we add the powers. This is basically our first law of exponentials. Our next law is once we are dividing and the bases or the variables are the same. These are what we call our variables here. Our variables, these here exponents, variables. Once the variables are the same or the bases are the same and we are multiplying, we add the powers. However, when we are dividing, we subtract the powers. And also note that anything raised to the zeroth power, is 1. So 3 to the zeroth power is going to give me 1. X to the zeroth power is going to be equal to 1. Anything raised to the zeroth power is 1. This is just an introduction to exponential. I know that you have found our basic algebra to be exciting and interesting, and so you would continue to develop your skills in the area of algebra. It's a very vast and diverse field. So look forward to meeting some more of these laws as you develop your skills in algebra. So we have come to the end of what we want to look at here today. When we come to our next video, we shall be looking at binary operations. So look forward to binary operations in our next video.